Hello everyone, and welcome back to the Fluctus Channel. Long before spy drones cruised at the edge of the stratosphere for secret missions, the US military was already experimenting with the idea of removing pilots from airplanes. Early unmanned aerial vehicles were simple, limited, and often unreliable, but they proved a powerful idea. A machine could scout a dangerous area, act as a decoy, or cross hostile airspace without risking a human life in the cockpit. Through the Cold War, improvements in radio control, telemetry, propulsion, cameras, and later satellite links steadily expanded what unmanned aircraft could do. What began as a small specialty in military aviation slowly became a major operational category. Instead of merely serving as expendable curiosities, UAVs evolved into tools for surveillance, targeting, reconnaissance, and persistent intelligence gathering. That evolution eventually produced one of the most important high-altitude surveillance aircraft in American service, the RQ-4 Global Hawk. The Global Hawk was never meant to look intimidating in the way a fighter or bomber does. Its design follows endurance rather than aggression. With an enormous wingspan of about 130 feet, long, narrow wings, and a smooth, bulbous fuselage, the aircraft looks closer to a glider than a warplane. That shape is exactly the point. The wings are built to generate efficient lift at very high altitude, allowing the aircraft to stay aloft for well over 30 hours at a time. The rounded forward fuselage holds sensors, mission equipment, and communication systems instead of a pilot, while the clean aerodynamic form helps the drone remain efficient over extraordinary distances. The result is an aircraft built to climb high, settle into altitude, and quietly watch enormous areas below. Cost figures often associated with the program place a fully equipped RQ-4 around the $220 million level, reflecting not only the airframe, but the advanced payloads and support systems that make the aircraft such a prized surveillance platform. What makes the RQ-4 so feared in intelligence terms is not speed or maneuverability, but patience. A crude reconnaissance aircraft may pass over an area quickly and leave with a snapshot. The Global Hawk can remain above a region for hours, sometimes longer than a full day, recording movement, mapping terrain, and helping analysts understand patterns rather than moments. That persistence makes it valuable for border monitoring, maritime surveillance, military observation, and regional intelligence collection. At high altitude, it can watch vast stretches of ground while operating above weather and far beyond the reach of many ordinary battlefield threats. Instead of rushing in and out of an area, it turns time itself into an operational advantage. That is the real power of a high-endurance drone. It does not simply see. It keeps seeing, long enough for its operators to understand how activity changes and what those changes mean. Yet the Global Hawk still depends on human judgment. Its cockpit is not inside the aircraft, but on the ground, where pilots and sensor operators sit before screens, control systems, and data links that guide the mission from far away. In practical terms, the cockpit has been separated from the airframe. The aircraft may be over a distant region, but the people controlling it remain on the ground, managing navigation, altitude, payloads, and mission priorities in real time. This changes the meaning of aviation without removing the human role from the process. The pilot has not disappeared. The pilot has simply moved to a safer and more connected location. On the ground, the aircraft also demands serious maintenance. Crews inspect the landing gear, engine, wiring, sensors, outer skin, and communication systems before launch because a long-endurance mission allows very little room for doubt once the aircraft departs. When the RQ-4 finally launches, it does not thunder into combat. It climbs, steadies, and begins the silent work of turning altitude, endurance, and sensor reach into intelligence for commanders below. Its long endurance also reduces coverage gaps because one launch can replace several shorter reconnaissance sorties and keep commanders watching the same situation without constant handoffs between aircraft and crews. That continuity matters whenever analysts are trying to connect isolated sightings into a broader pattern of movement, preparation, or intent across a large and changing battle space below. Another branch of unmanned flight looked not to the stratosphere, but to the helicopter landing zone. The Autonomous Aerial Cargo Utility System, or AACUS, explored how rotary wing aircraft could be modified to perform useful missions with far less direct pilot input. For demonstration work, a UH-1 Huey was fitted internally with remote and autonomous flight technologies that changed the way the aircraft could be operated. The goal was not simply to prove that a helicopter could be controlled from a distance. It was to show that future cargo aircraft might be able to deliver supplies into dangerous areas without exposing crews to the same level of risk. That mattered because cargo missions are often some of the most hazardous flights in war. Helicopters may have to approach rough landing zones, carry loads into contested areas, or fly in poor visibility and difficult terrain. AACUS was built around the idea that the operator should be able to focus more on the mission and less on constant control inputs. In simple terms, that points toward a future in which an aircraft can be told what to deliver and where to go, then manage much of the route and approach on its own. The modified Huey, therefore, became more than a test aircraft. It became a bridge between traditional manned aviation and a future where autonomous systems may help sustain forces, move cargo, and reduce the risk attached to dangerous resupply missions. In the demonstration concept, the aircraft could interpret mission instructions with much less constant stick-and-pedal attention from a human operator. That matters because every task a machine can manage reliably is one more task a crew member does not have to perform under pressure. For military planners, the attraction was obvious. A helicopter that can navigate toward a designated pickup or delivery point with greater independence could help sustain isolated troops, reduce crew fatigue, and open options for operations in terrain that is too risky for routine manned resupply. It also showed that autonomy in aviation does not have to begin with a futuristic clean-sheet aircraft. It can emerge inside a familiar helicopter, using software, sensors, and modified controls to change the way the aircraft works. That made AACUS an especially practical experiment for the services watching how autonomy might fit into real logistics missions. The lesson was simple. Autonomy could support logistics without waiting for a completely new aircraft design. At the opposite end of the unmanned spectrum is one of the most dramatic uses of pilotless flight, converting old fighters into live aerial targets. The United States has spent decades building full-scale target programs so that missile crews, radar operators, and weapons testers can train against something far more realistic than a small drone or towed banner. Instead of simulating a combat aircraft with a reduced-scale stand-in, the military takes retired jets and gives them a second life as unmanned targets that can still fly, maneuver, and present the radar characteristics of a real fighter. For years, one of the most famous examples was the QF-4, the unmanned version of the F-4 Phantom II. These aircraft allowed air defense units to train against full-size targets that behaved like actual jets, giving realism that smaller systems simply could not match. The end of the QF-4 era marked more than the retirement of an old airframe. It marked the transition from one generation of unmanned target aircraft to another, carrying forward the same idea with a newer and more capable jet. That next step was the QF-16. Rather than sending every aging F-16 directly to storage or scrap, the Air Force began selecting certain airframes for regeneration and conversion into remotely operated targets. The process is a remarkable example of extracting value from an aircraft long after its frontline career is over. Stored jets are inspected, repaired, updated, and fitted with the equipment needed for unmanned operation. What emerges is not a museum piece, but a functioning aircraft able to take off, climb, maneuver, and fly realistic threat profiles without a pilot in the seat. The QF-16 gives training ranges and weapons developers something that behaves like a true fighter, not a simplified target. That matters because modern missiles and air defense systems need to be tested against high-speed, full-sized aircraft that can challenge tracking and engagement procedures under realistic conditions. Some QF-16s fly repeated sorties before eventually being destroyed in testing, while others continue serving over multiple missions, proving just how much life can still be pulled from an old airframe. Taken together, these aircraft show how broad unmanned aviation has become. The Global Hawk turns altitude and endurance into quiet intelligence power. AACUS points toward a future where autonomous helicopters may deliver supplies without placing crews in the same danger. The QF-16 shows how retired fighters can become pilotless tools for realistic training and weapons development. Different shapes, different missions, and very different endings, yet all of them reveal the same larger truth. Once the pilot is removed from the aircraft, aviation can solve problems in ways that crewed flight sometimes cannot. Surveillance becomes more persistent, logistics become more flexible, and training becomes more realistic. The machine may change, the mission may change, and the level of autonomy may change, but the strategic value keeps expanding. That is why unmanned aircraft now stand at the center of intelligence gathering, experimentation, and combat preparation across modern air power. There is also a deeper irony in the program. Aircraft once built to carry a pilot into combat now help prepare newer weapons and crews without risking a pilot at all. The jet remains dangerous, fast, and demanding, but its value has shifted from fighting a war to helping others train for one. That transformation captures the wider logic of unmanned aviation better than almost any other aircraft program across the force today. That's the end of this video. I hope you enjoyed it. Make sure to subscribe to this channel so you don't miss any of our new content. See you next time.